So let's read the question. And then we'll break it down into small pieces. Here it is. Radioactive radium. Radium-221, it's just a name, has a half-life of 30 seconds. How long will it take for 95% of a sample to decay? In other words, only 5% is left. So 95% is gone. Okay? This sounds that, number one, that we are not given enough information, which is not clear, right? And it sounds kind of difficult. Let's read it again. So we are told that the half-life, 30 seconds, okay, that's a piece of information. And then we're asked how long will it take for 95% of the sample to decay? 95% of the initial mass to go away or decay. How long it takes? Okay. So one more time. I basically have only one piece of information. I'm only told that the half-life is 30 seconds. I do not have the initial mass of the radioactive substance. I do not have
Maybe
say it again.
you just use N0 as 100%.
So first of all, I sound so much better. Okay, so first of all, I have to identify the fact that this is a radioactive substance, number one. Number two, I have to write a model that says m of t equals m0 e, oops, not me, m0 e to negative rt. And I know that this is what I am going to work with. And secondly, I have to think in terms of what does this represent? In other words, I want you to give me an ordered pair. Ordered pair that represents the half-life.
See, like 130, 50, 30, something like that.
Careful, careful. Let's go back here for 1 second. Here we were told in 2 hours, 400. In 6 hours, this. What am I really told about half-life? When I'm told I don't have the original mass, but I know that this m0, unknown, this is my m0, will become half of m0
In 30 seconds.
in exactly 30 seconds. I want the ordered pair that signifies that.
30,
1/2 of
the,
m0. That's it.
Yeah.
That's it. So 30 seconds, comma, m0/2. That's all I need. Once you understand this, everything will be a piece of cake. So I have right here m0. I don't know how much, but I know for sure that this will become half in 30 seconds.
Yeah.
So that the ordered pair is 30 seconds, that the time has to be the independent variable, comma, whatever this is, divided by 2. Excellent. Good, so I want to plug this in. Exactly how we did with 2, 400 and 6, 25,600. The left-hand side. What do I replace this?
N0 is not number 2.
Yes, So this is the y
Okay.
coordinate, right?
Yeah.
So the left-hand side is m0 over 2 equals m0 e.
Negative.
Yes, exactly. Exactly. So when t is 30, m of 30 is m0 over 2. Okay, now let's look at this equation. You can say it's almost exponential, but I have to clean it up. So let's clean it up. Exactly. By what? Can it be 0? Because remember, I cannot divide unless I know for sure it's not 0.
Yeah, I can.
Right. So then I'm okay. I can divide both sides by m0. So then I have 0.5 is on the left. And on the right-hand side, I have e to negative 30r. And I'm in business. Now this is a pure exponential function. What should I do to both sides to get it?
Natural log.
Of course. Times natural log e, which is 1. So then r equals,
Natural log 0.5.
that's it. So with the graphing calculator, I will divide natural log 0.5 divided by negative 30. And this is 0.0231. 0.0231. So now I can go back. And can anyone dictate the model now? Whatever we have. Can anyone dictate what I should write as the model for this problem?
T equals 95.
We don't have that.
Okay.
M0 is M0. It wasn't
Okay.
given to us. We don't have 100 milligrams, 50 milligrams, 80 milligrams. E2,
Negative 0.0231.
that's it. Now I can read my question. How long it takes for 95% of the initial mass to go away? In other words, how long it takes for this to be only 5% of it? 95 is gone. So I have it right here in my hand. We wouldn't be alive if we had it in my hand. It's radioactive. So we have 100%.
Mhm.
So it turned to be left 5%.
Right.
How long it takes?
Right.
So we started with 100%. We started with M0. How much is left right now?
5%.
Percent
Yeah.
of M0. How do I write that? That's it. So we are down to 5% of M0 equals.
Zero.
Zero.
0.023.
And now,
Divide 0 both sides. 0.05 equals. Or 0.05. Yeah.
of course, with a calculator, natural log, 0.05 and divide by negative 0.0231. So time was measured in this problem in,
Seconds.
yes. So this radioactive substance will decay from whatever we had, 100%, it will decay to 5% in exactly 129.69 seconds. I want to add one more question here, and this is the end of chapter 4, and we can look at the review. When will the initial mass become half? Exactly like the question I added for the increase, for the exponential growth. When it decays to 50% of M0.
30 seconds.
I want to check.
0.5. M0 E raised to the negative 0.031 T.
Good. The reason why I thought I would trick you with this is because it is a formula. I don't use the formula, but I want to show it to you. You may. So this is natural log of 1/2 divided up by minus r, and that is the half. So to rearrange this, it's the formula in your book is natural log 2 over positive, because if you change natural log of 1/5, 1/2 into negative log of 2, and you simplify the negatives, that's what you get. So it's the same thing. So the half-life, say it again?
Say that one more time.
Yes. So T, or half-life, is natural log 2 divided by r. How do I get from here here? This is natural log 0.5, but natural log 0.5 is 1/2, or negative natural log 2, because this is 2 to negative 1, and I bring the negative in front. So then this negative with this negative will cancel, and you get this. You get the top to be natural log 2, and you get the bottom to be the r. So it's up to you. I think that the formula can come and go, but understanding what happens and being able to reconstruct this without even memorizing the formula is more useful, but it's up to you. So I want you to have it. So did we get 30?
Yes.
Of course, that's how we got all this. Very nice. Okay, I gave you some time ago this, right?
Yeah.
Okay, so let's browse through. We have 10 minutes, and let's say I want to do this now, this now, this now, this now, and the rest on Wednesday. So then we decided that our test would be sometime next week at your leisure, from Monday till Saturday next week. Is that okay?
Yeah.
Okay. Let me know if I need to have it by Monday, or I can work on it over the weekend, the test.
I'm probably not gonna take it till next Saturday.
Okay then. Okay, so please choose. So this is the end of of all this. So what is left are these. These are the conic sections, and these are series. Okay, so here we have 4 conic sections: circle, ellipse, hyperbola, and parabola. And then we're going to graph them. That's it. And here I'm going to show you how to determine going back and forth using the summation notation. Okay, so that will be the end of the material. And I wanted to schedule, I of course missed my class on Saturday as well, so I have to give them an hour next Saturday and an hour the following Saturday. So I don't want to teach new material because you may not be able to show up there, but I would like to review maybe for the final exam or, you know. So would you be willing to come on a Saturday, even if it's 1 hour and then another hour or 2 hours? Or
Is it the same class? The other class?
I will be here with them from 9 till 12 now
I mean,
for
is that
2
the same
sessions.
class as this class?
No, that
Oh,
no, that class is a O11 class. It's a hybrid.
Oh.
So let me know between now and let's say Wednesday, what would you like to do if you are available? Are you available Saturdays?
I prefer.
You are?
So you take like the Saturday.
Not this Saturday unless you want to come from 12. So any Saturday between now and the final exam. I would like to review for the final.
Okay.
I don't want to present new material. I want you to come and say, okay, let's work on these.
Okay.
So it can be even the 5th of May before the final exam.
I won't be in town that Saturday.
Okay, then we can do it before. Okay, so let's choose.
Can we do 9?
Yes, let's start with 9. Very good, good pick. Please redo all problems we did in class before you take the test, okay? You know I'm going to choose from what we, okay. So then tangent inverse x plus sine inverse y. When I look at this, I have to be able to identify these 2 pieces. I have to be able to identify what this represents and what this represents. Once I identify this and this, then the rest should be smooth, a smooth ride. So what is that piece?
And for both of them.
Very good. So I'm going to say this is alpha and this is beta. So I'm going to say let alpha be tangent inverse x. Then,
Beta equal to sine first.
good. And then what does this mean? Because I don't want to work in tangent inverse. Tangent inverse doesn't tell me much. So apply tangent to both sides. So then I have that tangent alpha equals x, which means there is a right triangle with an acute angle alpha. Yes, which makes the hypotenuse, which is the longest side, squared plus 1. Good. And now for this one. Same thing, sine inverse doesn't tell me much, but I can apply sine to both sides. And I have, exactly. So there is a different right triangle with an acute angle beta, not connected to this one, in which makes this one a difference. 1 minus y squared. Very good. Now, I have to come back to tangent. So basically, the problem is asking me to determine tangent alpha plus beta. Well, I have to dig deep. So this is tangent alpha plus tangent beta over 1 minus alpha times tangent beta. Yes, please remember this one. It's an important identity. So now piece by piece, I will replace those two and I'm done. Can anyone give us tangent alpha?
Square root of n squared plus one.
It's right here. Tangent alpha is x,
Alpha.
right? So x plus. Can anyone give us tangent beta?
X over y. I'm sorry, y over square root of 1 minus 1.
And I just have to copy them in the denominator. 1 minus xy over the square root of 1 minus y squared. I will find the least common denominator. So this is x, the square root of 1 minus y squared plus y. And the same thing, the square root of 1 minus y squared minus xy. And the only thing is I'm going to flip and the denominator goes away. So x, the square root of 1 minus y squared plus y. And no, you do not need to rationalize or do anything to this. Don't try to simplify it in any way, shape, or form because it's not possible. It would be greatly beneficial if you could do as much as you can between now and Wednesday from this, so we can finish it up on Wednesday.